In this example, we're asked to take a look at our function and to find out the x values where our function is going to have a decreasing gradient. Now, if I just take a look at this picture which I have drawn for you, and you don't have to worry about how I did it at this stage, it looks as though my graph is going to start decreasing over here and decrease all the way up to here. On the left of when x is minus 1, my graph is increasing, and on the right of when x is 5, my graph once again increases. If I want to take a look at my decreasing function, I must think about the derivative. As my function was given to me as a quotient, I'm going to find the derivative of f of x using the quotient rule. Now remember, the function at the top is the first function, and the function at the bottom is the second function. So when I find the derivative of f of x, I find the derivative of the numerator, which is going to be 2x, and I times that by the function in the denominator, x minus 2. And then I minus. I find the derivative of the function in the denominator, and I times it by the function in the numerator, and then I divide that all by the function in the denominator all squared. As the function in the denominator was x minus 2, I write x minus 2 all squared. Now the question asked, where is my graph going to be decreasing? In other words, where is the derivative going to be less than 0? If I take the answer that I got for the derivative as I have written down here, and I make that less than 0, you can see I've created an inequality for myself. Now all that remains is for me to simplify and factorize the left-hand side of my inequality. Simplifying the left-hand side, I'm going to get 2x squared minus 4x minus x squared minus 5, and that is all over x minus 2 squared. Now, because I want to find critical values, I'm going to leave x minus 2 squared all factorized in its bracket. By adding terms now, I find that I have x squared minus 4x minus 5, and that can very nicely be factorized. When I factorize it, I get the following two factors: x minus 5 and x plus 1. And I still keep that over x minus 2 all squared. You must remember that when you have an inequality, the 0 in the denominator is also critical. As I have now a fully factorized expression on the left-hand side, I'm able to find my critical values. I've got three critical values over here. The first one is when x is going to be equal to 5, then when x is minus 1, and then from my denominator when x is going to be 2. My next step is to take these critical values and to plot them on a number line. As minus 1 is the smallest number, I plot that the furthest to the left, and then 2, and finally 5. The next thing that I've got to do is I've got to look at my sign, and I want to find the decreasing intervals. In other words, the less than 0 intervals. I cannot use the critical values, and so I'm going to circle them as open circles to show that I can't use them. Whether I had been allowed to or not, I must always have the critical value that came from my denominator as an open circle, because the denominator can never be 0. As all my factors had a reducing degree of x, in other words, the x was at the beginning of each of the factor, and as there is no coefficient of a minus number, I can follow my rule, which says start on the interval on the far right. If the critical value has not been repeated, do not repeat the interval sign. As I had a plus on the right, I then have a minus interval next. But as the critical value when x is 2 was a repeated factor, I repeat the sign, as the sign on the right of it is a minus, it must be a minus again on the left. As with 5, minus 1 was not a repeated critical value, and so the sign changes. I've now identified the parts of the domain where my function is going to have a decreasing gradient. So the domain that I was allowed to use for a decreasing gradient for my function started when x was minus 1, went all the way up to when x was 2, but excluded 2, and then started again when x was 2 all the way up to when x was 5, but excluding when x is 5. Let's go back to our drawing now and analyze our answer. If I take a look at the diagram that I gave you earlier, we plotted when x was minus 1 and 2 and 5, and then we took a look at our intervals. We said to the far right I had an increasing gradient, and then decreasing on both sides of the critical value when x was 2, and then once again an increasing gradient on the far left-hand side. What happened when x was 2? Can you see that there is an asymptote? And that is because I would have had a 0 denominator when x was 2. So I can tend towards that value without touching it. What happened when x was minus 1 or 5? At those two places, the gradient of my tangent would have been a horizontal line. In other words, my tangent would have had a 0 gradient. So if I draw those in, you can see my two 0 gradients. The first 0 gradient was when x was minus 1, and the second gradient was when x was 5. You have now very successfully used your quotient rule for differentiation in order for you to take a look at a function and analyze whether it was increasing or decreasing.